Alright, so I'm going to go over the first 9 weeks review. The very first question says, which represents the graph of triangle DEF with vertices D at 0, 3, E at 4, 3, and F at 0, 7, and its image after rotation 90 degrees clockwise. Okay, so the key word on this one is 90 degrees clockwise. In most rotations, they won't tell you a direction, but you understand that it's going to be counterclockwise. But since this one says specifically clockwise, we're going to have to go clockwise for this one. Now again, normally it's counterclockwise, which is in more of this direction, but we're going clockwise because the problem actually tells us to go clockwise. So we're really looking at the second figure mostly on this. So all of the first figures are always the same. So in A, B, C, and D, the first figure is in the same spot. Now the problem, or the question actually is basically saying which one takes the shape and rotates at 90 degrees clockwise. So 90 degrees clockwise would move it from quadrant 1 to quadrant 4. Right? So quadrant 1 to quadrant 4 is both in A and C, but on B and D goes from quadrant 1 to quadrant 2. So we can eliminate B and D. Now the next part we want to look at is which one of these actually represents the letters correctly. The thing is, both of these are rotated to the exact same spot. However, if you look closely on here, on A, the top right one on the rotation is E. But F should have been the one that rotates to that position. So that kind of gives a little bit of problems, so that A is not the actual rotation. So the only correct answer is C. Okay, that then will take us to problem number 2, where it says, given segment YZ, construct its perpendicular bisector. On the test, you're not going to have to do constructions. However, you're going to be able to have to identify what construction was done. Okay, so for this one, we're looking at it. So with the construction of a perpendicular bisector, you get some distance about 2/3 the length of the segment, and then you put the rotating point on one of the ends, and you make an arc. Something like that. Now, I'm not using an actual compass on this, so this is going to be rough. And then you go and keep that same distance, put it on the other end, and make another arc that goes through. Now, where those two lines or arcs cross, you draw a line straight through to connect them. Now, this is a rough sketch. I did not use any actual tools for my construction on this, but it still is the same concept as what you would end up having to see on your problem. Okay, you have to be able to identify something like this if it's a perpendicular bisector. I remember there was also copying a segment, angle addition, postulate, stuff like that, where you had to copy an angle, where you had to make the angle bisector, those types of constructions as well. All you have to do is be able to identify what construction was done on the page to actually get credit for these types of problems. Moving on to number 3. If I am invited, then I will go. What is the underlying portion of the conditional statement? So on a conditional statement, that's the if-then statements. So after the word if is what you call the hypothesis. Right? After the word then is what you call the conclusion. So the one that we are actually looking at is our conclusion. Moving on to number 4, it says what rotation will map the figure onto itself. So with this one, you kind of have to look carefully at the problem. So notice on this one that we have this not matching up very well with the side here, but it does match up perfectly with the one on the bottom. So to get this side to meet the bottom, we have to turn it upside down. Turning it upside down is a 180 degree rotation. So we are going to take this and do a 180-degree rotation from the center. That takes us now to problem number 5. What's the first step to copy segment AB onto the line shown here? Alright, so going through this one, it says use the straight edge to draw line AB so it intersects the other line. So what that's trying to do is say we make a line that comes in and crosses into this line. When we're copying a line, we aren't really going to end up doing that. What you end up doing is you make a ray that you can just start off with a point. But we already have that line here. So the thing that we want to really do here is figure out how long exactly AB is. So the way that we figure out how long AB is, we definitely don't use a ruler to measure it. Okay. Again, on a construction, you do not use any rulers at all to measure it. You can use a ruler as a straight edge, but those measurements on those is something that you do not use. You set that compass to that distance. So we're making a compass this distance. We put the end point here, and we make an arc that crosses the line. Okay, that one was a little bit messy, but let's look at it again. Let's see, that would be something similar to it. Again, I'm doing it by hand, so we don't really have anything there. So, if we're going to do that one, and we're do an arc here, this would be the other point that would copy it down, and that would be D. So we want to actually first figure out how long AB is, so we set the compass to that distance. So the correct answer out of these choices is open the compass to the distance AB. That then takes us to number 6, where it says give the reason for the last statement in this proof. First off, starts off that angle 1 is supplement to angle 2, and it was given. Angle 3 is supplement to angle 4, and it was given. And then angle 2 is congruent to angle 4, which was given. Now they kind of skip a step on here, which is, again, not very good for them. But they really end up replacing angle 4 here with angle 2. So there should be another step in here with substitution, saying that they substitute that in. Now, since angle 1 is supplement to angle 2, and then angle 3 is now supplement to angle 2, you can say those two are congruent to each other by the congruent supplements theorem. If two angles are supplementary to the same angle, they have to be congruent to the same angle. If they change this one word in here for supplementary to complement, then it would be the congruent complement theorem. That then takes us to number 7. So on number 7 it says describe the transformation M, where it takes x, y, and goes to negative y, x. So the easiest way to look at this is to replace x, y with some numbers you can actually use. I like the numbers 1 and 4 because those are distinct enough that we can work around with them. So if I do the transformation to this, it becomes negative 4, positive 1. So I'm going to draw a quick little rough sketch. Alright, so 1, 4, right 1, up 4. Here is my first one, I'll call that M. And then the next one I go left 4, up 1, and I'll call that M prime. Alright, so looking at our choices, M goes to M prime, so that is a 90-degree turn counterclockwise. So our answer should be a rotation of 90 degrees counterclockwise. Now if it was going the other way, then it would be clockwise, but again, we're going to the left, so that is counterclockwise. Alright, that then takes us to number 8, where it says triangle IJK is congruent to a triangle LMN. Find the lengths of all the unlabeled parts. So here's the thing with this one. We didn't really necessarily discuss this, but if two things are congruent, the order of the letters matter. The first matches with the first, the second matches with the second, and the third matches with the third. So if I was to look at these, then I can just go with the angles first. J matches with M. So if J is 60 degrees, M is 60 degrees. Alright. I matches with L. So I is 90 degrees, L is 90 degrees. Alright, and then the last one would mean that K has to be 30 degrees. Alright, so if I have all these angles, then I can easily kind of just compare where everything else is. So the side with the 60 and the 30 attached to it ends up being 8 centimeters. And we can double check that. JK, second and the third, matches with the second and the third. MN, look, it does. IJ, alright, between 60 and 90 is 4 centimeters. IJ is first and second, matches with LM first and second. And that leaves the last side being 6.9 centimeters. So again, the first match with the first, second match with second, third match with third, they all match. And then takes us to number 9. When the point negative 3,2 is reflected across the y-axis, what's the resulting image? Alright, so here's the thing. We gotta remember the rule for y-axis. Okay? Anytime you flip over any particular axis, whichever our side you're flipping over stays the same. So our 2 is going to stay the same. The other one becomes its opposite. So the opposite of negative 3 is positive 3. So we would end up having 3, 2. Now, if you can't remember that, you can always graph it. So a quick graph. Alright, negative 3, positive 2. Alright, this is our y-axis. It was left 3, we go right 3. And notice we got 3, 2. Same thing. Takes us to number 10, which is a reflection over the x-axis. So the x-axis is the horizontal axis. So we need to figure out which one's flipping over the x-axis. So A, we got the top one, goes down to here. Looks like a possible flip, and that is the correct axis. So that's a possibility. And let's just double check that we don't have anything else. B, well, that's not in the same orientation. It does not look like a flip to me. So B does not work. C, yeah, well, that flips, but it's not flipping over the x-axis, it's flipping over the y-axis, so wrong. And then D, that's not a flip at all, that's a translation, so that does not work. So yeah, A was the correct choice all along. Alright, that will then take us to number 11. So we're going to just fill in the blanks with what we have and use that from there. So JHI, it's this section here. We know that that is 2x plus 7. GHI is 8x minus 2. The entire thing is 65. So, angle addition postulate tells us part plus part equals a whole. So that's what we're going to do. 8x minus 2 plus 2x plus 7 equals 65. Combine like terms, 8x plus 2x is 10x. Negative 2 plus 7 is plus 5 equals 65. Subtract 5. 10x equals 260. Divide by 10. X equals to 6. We just gotta plug in. So 2 times 6 plus 7, 12 plus 7, 19. Alright, so that eliminates A, B. Alright, and we have a 19 on both of these, but we can even already tell JHI is the one that's supposed to be 19, not GHI, so we really do have it being, oops, sorry, or not that one, it should be D. Alright, so D is the correct answer, but we can still double check to make sure that we did everything right. So 8 times 6 minus 2, 48 minus 2 gives us a total of 46. So we get 46, 19, and x being 6. And again, that would give us the correct answer to be D on number 11. Let's move on to number 12. Again, if you recall, if you're saying two things are congruent, first matches with first, second matches with second, third matches with third. So, we're trying to figure out which of these following are true. So TR and AN. TR is first and second, AN is first and second. Those match up. TI and AG, first and third, first and third. Good. RI and NG, second and third, second and third. Good. TI and NA. TI is first and third. NA is second and first. Does not work, so it is not D. Alright. T and A, first and first. Works out. R and N, second and second. Good job. I and G, third and third. That one works out as well. And then A and N, those are on the same one, so you can't really compare them to each other, so it's not going to be that one either. Alright, then that takes us to number 13, where we got another proof that we're going to work through. So we're going to go ahead and just fill out this proof, look at the ones that we end up having. Alright, so it says given angle 1 and angle 2 are supplementary, measure of angle 1 is 135 degrees. We're trying to prove that angle 2 is 45 degrees. So if I actually looked at this picture, that means this would be 135. And these make a straight line, so 180 minus 135 would mean that this has to be 45. So it does check out, but now we're just going to fill in the proof. First one was angle 1 and 2 are supplementary was given. Next one's the other given, which we know is measure of angle 1 equals 135 degrees. Then it says measure of angle 1 plus measure of angle 2 equals 180 degrees. We know that because they are supplementary, so this is definition of supplementary. Alright. And then we have the next one given to us where they substitute in 135. And the last part says measure of angle 2 is 45 degrees. They get that by subtracting 135 from both sides, so this is a subtraction property of equality. So now we just look at our answer choices, see which ones match out. So 2, measure of angle 1 is 135. Alright, so that's the first part. So checks out on A, checks out on B. C does not check out because it says measure of angle 2. And D, it checks out. Alright, so that one works. 2, it says definition of supplementary. On A, complementary. Nope. Supplementary, check. Alright, well, we've already crossed out C, so we don't need to worry about that one. And then supplementary, check. Alright, so it's going to come down to the last one. We're at subtraction property of equality. Checks out on B. Substitution on D, so it is not D. The correct answer is B. Again, we just go through the proof, figure out which of the steps are, use that to fill in the blanks. If you are confused on it, again, you're going to have things like this on the test, so you'll be able to look at the choices and figure out which one works. Takes us number 14. Which of the following is a line parallel to the line graphed below? So what we need to do is look at where we can figure out points and slopes from the line. So we've got this point here at 0, -3, this point at 1, 1. So to figure out this slope, we're going to go up, and that's an up total of 4, and a right 1. So our slope is 4 because we do rise over run. Alright, so we want to get this in slope-intercept form just to make sure, because if it's going to be parallel, it has to have a different y-intercept. Alright, so we look here, it goes to -3, so the slope intercept form is y equals 4x minus 3. Right, so we can't have the same one. So that eliminates A from being a possible answer. Now, if we look at C, the slope on this one's -3x. So is that the same as 4? No. So we can't use C. Let's look at B. We have to add 4x to both sides. And that gives us y equals 4x plus 7. So, slope's 4, y-intercept's different from -3, so that one works out. You just have to make sure that the slope is, or the y-intercept's different if the slope's the same. And we can just double check anyway here. Minus 4x gives us 3y equals to -4x plus 6. We'd have to divide both sides by 3. So if we do this, we end up getting some slope of -4/3, which is not going to be parallel. So we were good with that one. It's definitely not D. That's then going to take us to number 15, where we have another line that we have to figure out is parallel. We're given the slope of 3/4. So if our slope is 3/4, for it to be parallel, it has to have the same slope, different y-intercept. So let's look at these ones. -4/3, nope. -3/4, nope. +3/4, that's the same slope. Is the y-intercept different? -9, yes it is. And just double check, 4/3 is not the same slope. So correct answer on this one is B. Alright, so we've only got a couple more problems to go. And same graph as we had before on the rotation, but now the difference is that we are given a translation. So with it being a translation, we just take the figure, and if it's x minus 4, y minus 5, we've got to go left 4, up, or down 5. So if we look at A, the figure is going right and down, not A. We look at C, right and down, not C. So B, left, 1, 2, 3, 4, down 1, 2, 3, 4, 5. Alright, that one looks like it might work out. Let's just double check that D is not the same one. Left 1, 2, 3, 4, 5. Ooh, that's not good. So we want to only go left 4, so the correct answer is B. Alright, so then that will take us to number 17. So number 17, where it's another proof where we have to fill in the blanks. Alright, so for this one, provide the reasons for statements 3 and 5 in the proof. Angle 1 and 2 form a linear pair. Measure of angle 2 is 100 degrees. Prove that measure of angle 1 is 80 degrees. So it starts off, measure of angle 2 is 100, given. Measure of angle 1 and 2 are a linear pair, given. And then it says measure of angle 1 plus measure of angle 2 equals 180 degrees. So this one would be the supplement theorem. Alright, if you know that two angles form a linear pair, then they have to add up to 180 degrees. So that's a supplement theorem. Alright, then we have where they substitute measure of angle 2 with 100 degrees by substitution property. So then they subtract 100 from both sides, so that's subtraction. Property of equality. Alright, that takes us then to number 8. For the conditional statement, write the converse and a biconditional statement. Their conditional statement is, if a figure is a right triangle with sides a, b, and c, then a squared plus b squared equals c squared. So a converse is when you switch the orders. So for a, if a squared plus b squared does not equal c squared, there's already a big flag on there because it changed the sign to the opposite. Okay, so but they did switch the order. So this first one is not the converse, that's the contrapositive. So this one does not work. Alright, so we've eliminated A. Let's look at B. If a figure is not a right triangle with sides A, B, and C, again, wait, here's that word again, not. So it's changing the meaning of it. So if it's still in the same order but changes the meaning, that's the inverse. So again, this is not the converse. Alright, the next one. If triangle ABC, or if a squared plus b squared does not equal, oh wait, that looks kind of familiar again to what we had at the top. So no, it's the same reason as the first one for the converse being wrong. So then that just leaves us one extra option. Let's just make sure that not all of them are wrong. If a squared plus b squared equals c squared, okay, so it's not a not, we're good. It's just switched. It back came to the front. Then the figure is a right triangle with sides a squared, a, b, and c. Alright, works out. Biconditional takes the first part if and only if the second part. So a figure is a right triangle with sides a, b, and c if and only if a squared plus b squared equals c squared. Yeah, that works. So D is the correct choice. Alright, so then that's going to take us to number 19. Alright, so triangle AB or AX or XYZ is reflected across the y-axis. Then its image is rotated 90 degrees about the origin. What's the coordinates of the final image of point X under the composition of transformations? So it's only X that they're worried about, so don't even worrying about any of the other ones. We're going to take X, reflect over the y-axis. The y-axis is going up and down, it's 2 to the left, goes 2 to the right. So here's the first X prime. Then we rotate it 90 degrees. So 90 degrees, if it does not specify, is counterclockwise. So it's got to move to this quadrant. So if it's this quadrant, we have that to be where it has to be negative and then positive. So you can kind of double check to make sure that that works out. The only one that's negative and positive is A. But also, you can just take your paper and turn it to the left. So if you turn your paper to the left, then you can see where that point's going to be. And it actually goes to the left 3 up to there is X double prime after you've done both transformations. Alright, last problem. Which of the pairs is perpendicular? So we have to look at the slopes again. So A, it's understood that there's a 1 in front of this X, so the slope's 1. Alright, the slope of the other one is negative 1/2. Alright, so negative 1/2 is not the opposite reciprocal of positive 1. So it is not A. Alright, so let's look at B. 4x and 4x. The slope of those are both 4. Alright, the slopes are the same, which will make it parallel, not perpendicular. So it's not B. Alright, C. We've got 3 and 1/3. Alright, so it does flip the sign, or flip the fraction, but the sign's still both positive. So that is not enough to make it perpendicular. So it's not C. So the very last one, 3/4 and negative 4/3. 3/4 flips to become 4/3 and the sign changes. D is the correct choice. Alright, so this was the first 9 weeks review for the test. Alright, Hopefully this is helpful. Uh, Thank you. Bye.